we have the speed of automobiles on a particular highway and a random sample of 28 automobiles. We are assuming a normal population distribution and we want the margin of error of a 95% confidence interval for the mean speed. We will use the sample mean to estimate the population mean. Since we have a normal population distribution, we know that the sample mean also follows a normal distribution. However, the population standard deviation is not given, so we need to use the t-distribution instead of the normal distribution for the sample mean. Now let's take this sample and put it into R so that R understands it as a vector. So we will use the C function to combine these values into a vector, and let's call that vector sample. And we can clean this up. Okay, if we click run, then R understands this vector. Now, what is the sample size? Let's take the length of this vector. And we can give it a name, n. So save the length of the sample in the letter n. If we click run, we get 28 up here. Now let's also calculate the mean of the sample and call it m. We get the mean. And we take the standard deviation of the sample and we get 5.23. What else do we need? We need a critical value. For a 95% confidence interval, well, the critical value would be at 97.5% because we have 95% in the middle and 2.5% on the left and on the right. So we take 2.5 plus 95, so we get 97.5%. So QT finds the critical value 0.975. And how many degrees of freedom do we have? N minus 1. And let's save that critical value as t. When we run, we get the critical value up here. Now the margin of error is just the t critical value here times s divided by the square root of the sample size. So this is our answer, 2.028. If we also do the confidence interval, we have a lower confidence limit and an upper confidence limit. The lower limit is the mean of the sample minus the margin of error, and the mean of the sample plus the margin of error. And let's print these values. We can print the margin of error, the lower confidence limit, and the upper confidence limit. And we get the answers here. So if we go up from 60.89, 2.028 steps, we get to this value. If we go down, we get this value. Now we can also compare these results to an built-in function in R called t-test. And if we run, we can see that we get a 95% confidence interval ranging from 58.86, the same value as here, to 62.92, same as here.